Today we're going to do 3-22 and 3-23. So the key with these pages is the idea that in a triangle, the smallest side is always across from the smallest angle. All right. And then the largest side is also across from the largest angle. Okay, concept you've probably learned before, but that's what we're going to apply here. So we want to put these in order from shortest to longest, and the way we make this a little bit more honors is we have triangles that connect. So what I'm going to do is I'm going to focus on this triangle on the left, so triangle ACD, and looking at this, I know that angle is right angle, that's 75, and then this would be 15. So just looking at this triangle, I know AD is the smallest, then CD, and then AC is the longest. Okay. Now I'm going to look at this triangle on the right. That's 15, that's 75, and then a right angle. So here I know that CD is the smallest, then it goes BD, and then it goes BC. Okay. But then there is one last triangle, which is the big one. So if that's 75, that's 15. This whole thing is a right angle. So that would mean that AC is smaller than BC, which is smaller than AB, right? So now if you notice, there's some connections between each of these. So the smallest is AD because this guy and this guy are the same. So that means all the sides in this triangle are bigger than AD. And then similarly, AC is in that as well. So then we know that AC, BC, and AB are all bigger than AD and CD based on this, right? And then we also have another little connection here that this guy is here. So we know AB is bigger than this biggest side. So we know AB is the largest. So kind of using this logic, these three inequalities, we're able to put these in order. So based on what's listed, so we know AD is the shortest. Then what's here next would be CD. Then CA, which is AC. Then BC. And then last would be AB. So here is our answer for shortest to longest. Okay. So number 2, kind of the same idea, but this time they just want the longest one. So this one we have to be careful with. Again, this one throws a lot of students off. So I'm going to focus first on this triangle here. We know this angle would be 55. So I know that based on this, I know KR is the biggest. So let me do it this way. It is bigger than the other two sides because the other two sides are actually congruent. So TK and TR because they're both 55s, and then across from the 70 is KR. Then if I focus on the other triangle, oops, so KIR, here I know that's 50, that's 60, which means this has to be 70, which means KR is our smallest side, then it goes RI, and then KI. Well, there's always going to be, oops, sorry, my pen stopped working there for a second. There's always going to be some connection between our inequalities when we write this, and you'll notice KR, well, KR was the biggest in the first triangle, but it's actually the smallest in the second triangle. So that means if we want the longest segment, it's going to be KI. Okay, and that's our answer for this one. All right, kind of continuing on, so page 3-23. These are kind of, this is actually all review. So what I would actually recommend you doing is pause the video here, try these out, try out all 5, and then come back and I'll go through this still. All right, so hopefully you did these. So the first one, if the altitude, angle bisector, and medians are distinct segments drawn from the same vertex of a triangle, which of them is the longest? Well, we can draw this out so they're distinct segments, which means we do not have isosceles, we do not have equilateral. We actually would have what's called a scalene triangle, right? So what ends up happening here, if you draw out the three of them, and we would be able to do this more proof. The proof would be longer, but what ends up happening is this one that is our median. Again, I didn't draw this super well, but if I drew this more carefully, you would clearly see that this one is longer. But you can kind of use the same logic that we just did. So in this case, median, I'm actually not even going to write, I'm just going to circle it. The medians would be longest if they're all distinct. And distinct, by the way, means different. All right, so then number 2, if one side of a triangle is 10 and the other is 15, what is the range? So this is triangle inequality. So the third side would have to be between 5 and 25. But they're asking for the perimeter, which means you just add those on, all three things together. So 10 plus 15 plus 5 is 30. And then 25 plus 15 plus 10 is 50. And there's our perimeter range. All right, number 3, triangle ABC, ABB, name the largest angle. So if you need to draw it out, so ABC, oh, that doesn't look like a B. So AB is 8, BC is 10, and CA is 14, which means angle B is our largest angle because it's across from the largest side. All right, number 4, this one, triangle RIT. We got this guy, and then RT is 12, TI is 14, and then there's P on TI such that TP is 6 and PI is 8. Which of the following is true? So now what we're going to do is we're going to draw in that line. And excuse me, we go ahead and we start going through all the different angles. Oh, I'm sorry, I missed one of these. I was like, wait a second. So now we have everything. So we are able to then determine which one's the biggest side, or sorry, biggest angle compared to the other. TRP ends up being bigger than IRP. And it's using triangles, but it's the idea that they have the same two sides. This angle is going to be bigger if the side across from it is bigger. So that's why TRP is smaller than IRP. All right, and then number 5 was a straight, just very similar to the ones we just did. Hopefully you tried it out. It ends up that of all these answer choices, they are all not the right ones. The correct answer would have been AC, but it is not an answer choice. Yeah, thanks for watching. Have a good day.